Let me start with some introduction for this course. So basically, what this is. So it's just, as you saw, a Solidity course, because a lot of external apps are coming. A lot of you maybe have ideas to create external apps, or just, switch a bit context, and instead of working on front end and back end, you just want to try out, or DevOps, you want to try out a bit of Solidity, which sometimes can be a bit frightening, because you say, like, hey, you can easily fuck things up, let's say. But it's just because, and you will see it, like Solidity is a very actually simple as a language, but this simplicity comes with a lot of, let's say, possible issues, bugs. It's a very new language. So yeah, like we need to to know what we are doing, right? But once you know actually how it works, what you're doing, you will see that you won't feel that pressure, or don't want to be anxious about writing Solidity code or interacting with contracts. So this lesson in particular will be a bit for like a lot of basic knowledge about Solidity, about the environment that we will set up, to write the contracts, to test the contracts. And I will also try to put a sort of, we'll try to do, let's say, a sort of example, a sort of application. The time is not much, because it's like 1 hour and a half. So let's see if we will be able to put it in. Otherwise, like if I won't be able to put everything I want to talk about in this lesson, we will maybe shift the next lesson somehow, which will be actually a lot important the next ones, because in the next ones we will cover more advanced topics like access control, upgradable smart contracts, what they are, how to build them, how to upgrade the contracts, and checkpoints, which are very important, because you can basically track a sort of history on the blockchain, which is very cool. How to optimize gas by using libraries and stuff like that. Piero will cover those two, the next two lessons about these more advanced topics. And finally, at the end, we will touch also some even more advanced, let's say, topics that could be, like, for example, account abstraction. There could be, I don't know, like building governance structures and projects. And stuff like that. So we'll touch also, I don't know, like oracles, a lot of stuff. So the objective is that, as I said, like at the end of this course, basically everyone will be very confident in reading Solidity, writing Solidity, deploying whatever they want. Okay. So one thing, since, as I said, the time is kind of short, I will try to go fast, let's say. So if you have any questions, let's try that you write them down, or in the chat, or just write them down on some paper yourself. And like at the end of the lesson, if you have some time, we will cover those questions, or otherwise we can cover them offline, right? Like we have our Slack channel, so we can discuss also there. And I will create a repo also in this during this lesson. So and I will make it available at the beginning. It will be internal, then we can even make it public. Okay, so don't worry. At the end, you will have the link to the repository, to everything that we are doing here, and so on. Okay, so I would say let's start, and let me first share my screen. Okay. Okay, so here I was preparing the repo that we will use later, but let's start from something very, very basic, from like the beginning. So what is Solidity? So let's create, like, of course, Solidity is like to build, let me move this one here. Okay, so Solidity, of course, its use is basically the language for EVM blockchains, like Ethereum, like Polygon, like Avalanche, like everything that was forked from them, and of course also for VeChain. So like if you want to build something that interacts with the blockchain, you want to create a decentralized application, you will need to build some smart contracts, like, or interacting with some smart contracts someone else built, okay? So what is a smart contract? It's basically just a Solidity file, and let's create one. So let's say test contract.sol. So you recognize Solidity files because they end with this sol at the end. And there are basically four like four basic information that you have to write in this file in order to have it like have a actual smart contract. So the first thing, you need to add the license. Like, is this what type of license? Because everything is kind of public, right? So they introduced this in the last years that it's mandatory that you write the license. So you do it like this. You basically, it's a comment at the top of the file, and you just say SPDX license identifier. Yeah. So what's this? Okay. Yeah. So license identifier, and you put Smith, and that's kind of the basic. And then what you need to do, you need to define what version of Solidity you want to use. Okay. So we put here 20. So what is this? SPDX, sorry. Okay, so basically, Pragma, you specify, as I said, the version of Solidity. So the language itself, it's people are updating it, and they release new versions with new features, new things that you can do with Solidity, optimizations and stuff like that. So in here, you basically are specifying exactly like what specific version do you want to use, of course. This is one of the late, I think the latest one at the moment is 0.9. Okay, that's, if I'm not wrong, the latest version available of Solidity. But as I said, every new version introduces new features. And since on VeChain, we are basically like not aligned with Ethereum 100%. Sometimes we cannot use some specific features that are there in the latest version of Solidity. So currently on all the projects on VeChain, like this version is okay. And it's also very recent, so you can just go with this one here. The next thing, we need to define our contract. So this is the important keyword. So we say contract, we name our contract, and the best practice is to actually name the contract in here as the file name. So if we call this test contract, here we say test contract as well. And then, and this will be already enough, okay? So this is already a smart contract, okay? You can add something on top, which is the constructor. So the constructor is basically when you deploy the contract, it's a function that is being executed only one time during deployment, and you can do things in there to initialize variables, to set something, and we will see it later, stuff like that. But like if you don't put, like if you don't have anything to initialize, you can even avoid this piece. But let's say that this basically, it's a smart contract. It's the basic of a smart contract, and you could even deploy it. Okay, of course, this does nothing because it's empty. But this is kind of the basic. So every time you say like, okay, I need to write a smart contract, you will need to write the following 4 lines, okay? And then starting from here, you will start add your logic, variables, and whatever, okay? So this is a Solidity file, though, right? So when you actually deploy your, when also your smart contract is deployed on chain, and like it's not actually stored as a Solidity file. It's actually be like when you deploy it, to deploy, you need to compile it first, okay? So compiling it first, it means that everything you write in here, this is kind of a sort of readable language, right? So it's for developers, so you can write your code, it's readable, you can share it, and so on. But from this point, it will, when you compile it, all your code is being converted, first of all, in assembly, which is a sort of low-level language, okay, to interact with the blockchain, okay, with EVM blockchains. And from there, it's actually then transformed into bytecode, okay? So, and only that bytecode is actually stored on chain, and that's it, okay? In the middle of this, in this process, another file is being generated, which is the ABI, okay? ABI is basically a very big JSON that where all your functions, everything about your contract is being stored inside there, and you will use that file to know exactly like what functions there are there, like what parameters they accept, what they return, what type of visibility they have, and it's used like for front ends or back ends, like for everything that needs to interact with that contract from outside the chain. Okay, so inside the chain, like I deployed, if I need to talk one contract to another contract, it's bytecodes, you know, and stuff like that. But if I'm outside, I'm building a front end, I'm building a back end, whatever, I will need that ABI to actually know like what functions are available and so on. So okay, so this is the basic, but in order to be able to compile it, to deploy it, we will need an environment set up, right? Because otherwise I just kept this file and like, okay, what do I do next? Okay, so let's take some minutes to actually, before going further with Solidity and all the basic stuff about it, to just install our environment, to understand a bit more about it, to see a few things. And yeah, so then we can just start programming, let's say. Okay, so the environment usually that it's being used is Hardhat. Okay, so if you go here, you will see that this is basically, yeah, as I said, Ethereum development environment, but it works for all the EVMs. So you can just install it. It will cover you with testings, with testing, with deploying, compiling, and so on. But since on VeChain we are not 100% aligned with Ethereum, we don't have an RPC, for example, and so we actually need to tweak a bit this environment to be able to work with VeChain. There is a very easy way to basically let's say start, and we created a starter kit, okay, for Hardhat. So to use it, it's actually very simple. We have this. Let's go to docs, VeChain docs. So if you go to the VeChain docs and you go inside the developer resources, getting started, you will see here that we have this quick start with VeChain templates, okay, which are basically pre-built templates that you can use to really start developing pretty fast, okay? So in here, we are at the moment have 3 templates. The extern app template, which has like a React, Express, a backend, ChatGPT for image recognition. We have another simpler template, which is just React with Hardhat for development. But sometimes you don't actually want a front end, right? You just want to build your smart contract to test them, and that's it. So for those scenarios, we also added this smart contract template, which has Hardhat development environment, as I said. It has a lot of contract, we will see it later, like already smart contract templates, mocked smart contracts for interacting, like let's say with VeBetterDAO, stuff like that, some helpers. The infrastructure is already tuned to just work out of the box. So yeah, so let's use this one. So to do it, we just use this command. So let me let me clear everything. Okay, let me just create, yeah, let's go here. Okay, so as I said, we just execute this command. So npx create VeChain dApp, and we can choose between the template that we want to use. And what we are interested at the moment is the Hardhat template. So let's call it Solidity Masterclass. Okay, and it's done. So we go inside here and we open our folder and let's look what's inside. Okay, so first of all, we have, yeah, you have the README with everything, and here it talks about the installation. So some prerequisites that we need Node.js, at least version 20, Docker to run the Tor Solo, which is the blockchain running locally, right? And so let's just follow the installation procedure, and then we can continue. So we need to run yarn install. Let's do this. Okay, and then we need to create an end file. So where is it? It didn't create it. Okay, let's just, okay, here it is. So in here, what we will need is the mnemonic, because to deploy contracts, right, you need some wallet, okay? So this mnemonic here, it's the mnemonic that is used on Tor Solo, which comes with a lot of accounts filled with Ethereum. So you already have money, you don't need to worry about filling those accounts and stuff like that. We sometimes also use it on testnet. Of course, it's not recommended to use it on testnet because everyone maybe is using it. So you can have, maybe you don't have funds or stuff like that. But yeah, for this tutorial, let's just use this one. Okay, so we have our, right now, basically our setup is ready. So we can, let's take a look at the structure of it. So we have our folder here, which is contracts. So this is the main folder where we will store and write our smart contracts, okay? And you can see that there is already like a simple contract that we will take a look in a second. As I was saying, there are some templates. So for example, this is a template for creating upgradable smart contracts. So you can just copy paste this, update some, change the names, and you have an upgradable smart contracts. There is a template for creating modules, and we will talk more in the future about this. But yeah, we have some templates. We have some mock smart contracts. So because, for example, if you're building an app for VeBetterDAO, right? And you want to interact, I don't know, with the Better token, or you want to interact with rounds, allocation rounds, and stuff like that. If you deploy in testnet, maybe there are already some smart contracts deployed, and you can use those. But if you need to test them locally, like you would need to, you won't have them, so you will need to write those contracts. So here it's already provided, basically. And then we have some helpers that we cover in the future. So, but basically this folder here is for the smart contracts. Then let's go next. Then we have another folder, which is the scripts. So in here, what we have is the deploy one with the deploy script. So this one is being executed each time you want to deploy, but also like in the tests, we will see a bit. So this one here is being executed, and it's actually calling a function inside the helpers. So like to deploy a contract, what you do is basically those are the 3 lines. Okay, the 3 lines you will need always when you want to deploy a contract. The first one is like, okay, I want this contract. So you just specify that you want this contract. The second one, you say like, okay, I want to deploy this contract. Okay, and you can pass some parameters, and you can pass like some other options. And the third line is like, okay, let's wait that the deployment completed. And after that, you have your contract deployed, you can get the address, you can interact with it, and we will see more in the future. But yeah, basically this file here, like this one is calling a function inside here. So everything you need to, when you need to deploy, you put it inside here. We have also some helpers, like for example, for deploying upgradable contracts. So you see here, like we have deploy proxy, initialize, upgrade, deploy and upgrade. We will, as I said, we will touch this in future lessons, but yeah, we have some helpers. And that's basically it about the scripts folder. Then another important one is the test folder. So in here, you will write all your tests. And basically how you test, you just deploy your contracts and then you interact with them. And we are using the chai testing library to say like, okay, I expect that this, for example, check that the contract is deployed, right? You say like, I expect that the address of this contract is not the 0 address. So it actually is deployed on chain, or like, I expect that this value is 0 or whatever. Okay, so we'll see more about this, but yeah, testing is very important, because when you write Solidity smart contracts, you don't have any way, let's say, to actually test that what you're doing is correct. Like, of course, you can compile your code, and if something is wrong, it won't compile, and it will say like, hey, there is some issue. But if everything works like it's compiled correctly and you deploy it, like the only way to actually test that it's working is like, or you write some tests in here where you interact with your contract, or you actually need to build a front end, okay, and interact from them. So of course it's not very scalable to write a front end in order to manually test every time your contract, right? Okay, so let's move a bit. And we have, here is a Docker file, and this one is used to run your Tor Solo instance locally. And this is another very important, like this is kind of the heart of Hardhat, which is the config file, okay? So let's see a bit what's inside here. So first of all, as I said, we needed to tweak a bit this framework in order to make it work with VeChain. And to do that, we have this SDK Hardhat plugin, okay? So just by importing this one here, it will basically like the guys from the SDK created everything that it's needed to, instead of using RPC, to actually do an HTTPS call and stuff like that. We also have, like, you can use directly the delegation features, multi-close directly, like in here. But for now, we don't need it. So we just need it to actually be able to interact with the chain and work. So that's one thing. And I also installed here some other utilities packages, like, for example, a way to see the coverage, the test coverage of your Solidity contracts, a possibility to generate documentation based on the comments that you added on your file, a plugin to, for example, get the size of the contracts, because, and we will touch it later, size is also quite important when writing Solidity smart contracts, and generate interfaces and stuff like that. We'll see the comments in a second, but let's move on. So another thing important here is the derivation path, right? Because if I use my this mnemonic, like, in order to have the correct VeChain address, we need the VeChain derivation path, okay? So this is just a constant that we will use in the file here. But let's look inside the actual configuration. So in here we have the first thing is, like, we need to specify the Solidity version, okay? So, like, all about the compiler. So we say, like, okay, we will use the compiler that will compile like this specific version of Solidity, which is the same that we were talking before, the 0.8.20. And then we need to specify the EVM version. So Apart from Solidity, EVM, so virtual machines also get upgraded, right? And they have different versions. We are not 100% aligned at the moment with the latest one, which I don't remember the name at the moment, but just use Paris like this and it will work fine, okay? And then we have this other, it's quite important as well, which is the optimizer. So what this does is that when you compile your smart contract, it will go here, it will check if the optimizer is enabled. And if it's enabled, what it will do, it will actually run calls against your smart contract this amount of times that you specify here. So in this case, like 200 times. So the compiler will just start running calls to the smart contracts. For what reasons? To see if there is something that can be optimized, right? It's an optimizer. So, so something can be optimized. And when I say optimized, I mean like, okay, can some variable be declared like in this place instead of this other place? Can some function be change visibility, or like the compiler will just it won't disrupt your code in any way, but it will just try to see like by changing the order, maybe you can spend less money when interacting with the contract and when deploying the contract. Okay. So yeah, this you can tweak it, you can put it. That there are some times when you don't want it, or you want it to run only one time. Other times, for example, with contract sizes, sometimes if you run it too much time, let's say 200 times, yes, it will optimize the gas consumption of your functions, but it's possible that it will make the size of your contract higher. And we have some sort of limitations in Solidity that we will touch in a bit, where basically if your contract has the size like is bigger than the limit, then it won't deploy it, okay? So sometimes you're like, okay, I really need to switch this off or just run it only one time because I want optimizations, but at the same time, I don't want to increase the size of my contracts. So let's leave it here. Then this is contract sizer. So basically it's just, I installed here some plugins, let's say, and so it's just some settings for that. This is the settings for the test. So it says like, okay, it will wait this specific amount of time before, like to wait for the test to end. Otherwise, it will just give an error and the test will fail. Some settings for the gas reporter plugin. And then here we have an important piece, which are the networks, okay? So let's see what are the networks. So the first one is Hardhat. Okay, so Hardhat itself has a sort of EVM that you can use to run locally. You can see it as like the VeChain solo version, but for Ethereum, and it's a lot more light, let's say. Okay, so this is comes with Hardhat itself, with the framework. So, and it's very useful, for example, when running tests, because it's very light and it's like to run tests, it just takes a lot less time than, for example, interacting with VeChain Solo, which it's true that it's not like it has like features like I don't know, mint. Create a block on demand, like every transaction is a block, so you don't have to wait like 12 seconds or stuff like that, but still it takes more time than just using Hardhat. Okay, so this one is one of the network, and I also put it as the default network, which means that, so that, for example, if I just say run the tests, it will say like, okay, I will run them against Hardhat network, okay? What we have here is also VeChain Solo. As I said, it's our it will spin up on our local machine. So the URL, we put here we have an array for the accounts. We put here the mnemonic, our VeChain derivation path, and some settings for the gas limits of gas usage. Then we have VeChain testnet, which is pointing to the testnet, and VeChain mainnet. Okay, and that's it basically. So let's just quickly view a few things. So let me clear here. So let's run some comments that will also explain us a bit what I was talking previously about the compilation, right? So let's try to compile. We have a contract here, which is the simple storage. So what it does, it just has a variable. We have a function to update the value, and we have a function to read this value, okay? So let's go to our package.json here. And let's say yarn compile, and let's see what happens. Okay, so first of all, what we see on the screen. So on the screen, we see this is the package that we installed, which you will see all the size of your contracts. Okay, the limit for Ethereum is 24 kilobit. Okay, so when you see here reaching 24, 20, like you know that okay, you will need to stop adding functionalities inside that contract. There are some way to not reach that limit that we will cover in more advanced lessons, like using libraries or yeah, basically like using libraries. It's one of the best ways. But yeah, this is what we see here. And why we see all of this? Because in this folder, I added a lot of contracts, right? We have the templates. So for example, you see here base upgradable. I can also find it here, right? So this is like, it just compiles everything it finds inside this contracts folder, okay? And he says like done, everything compiled successfully, so nice. And what it does, it creates a few folders. So the first folder it creates is the artifacts folder. So in here, it will store basically the output of the compilation, okay? So what we can do, we can go inside artifacts, contracts, and here we see, like you see, helpers, mocks, templates, and simple storage, which is actually what we have in our contracts folder. If we open this file, we will see a few information. So this is the ABI, right? That we were saying before, that it's used to interact, like you use it to interact with the contracts. So if you look a bit in here, you see like it's just an array with those with this JSON where you say like, okay, we have a function called get value that yeah, it's a function, it's a get value that returns an integer. Okay, this is the output. Then we have another function which is set value that returns that accepts as a parameter an integer. Okay, so basically on your front end, yeah, you just know that okay, we have this function, we need to add this parameter as an argument and so on. And what we have also, it's our bytecode. So this is the bytecode I was talking about. So everything is being compiled and like everything ends in here. So this is basically our smart contract that is being deployed on chain. Okay. So this is one thing that it created. Another thing that it created is this Typechain types. Okay, so it's the same thing. If you open contracts, we see our simple storage, and it's just basically our ABI, but typed. Okay, so we can use it with TypeScript. So for example, if we go here, you see we have get value, set value, get function. It's a view, it's non-payable, and you can see basically everything that this contract is doing. So, so you can use it in your front end or back end, whatever, with TypeScript, right? So you are type safe. It will be your IDE that will say like, hey, you need here a variable. Hey, like you're doing this wrong because this accepts an integer, but you're passing me a string. So this won't work, right? Okay. So those are basically the few, like the most important things, right? So we compiled it now. Let's see what other commands we have here. So we have the deploy one, the deploy command. So you can just say yarn deploy Hardhat, and it will deploy on the Hardhat network, okay? Or you can say yarn deploy, uh, yeah, let's do test now. So you see, it says, okay, this is the deployer address. It's now deploying. Let's give it 1 second. Okay, deployed it. So if we take this address and we go here, we go to site chain. Okay, and we go to our testnet. For this, you see, it actually like it says like runtime bytecode, the master, that it's a contract. You can see the bytecode. So, and you can see the event, and this is just the contract creation event. You see new master, stuff like that. So yeah, it's deployed on our testnet. And now here is the thing I was saying before, right? So basically, okay, now we have our contract and we even deployed it. Okay, how can we test that it works? So one way, of course, is to write test, and I will run the test in a second. Or another way is if you create a front end where you build it in a way to actually call the specific functions. So we have this cool thing, which is the inspector on VeChain, where what you can do, you can basically, if you can add a contract. So let's say this is our simple storage contract, right? This is the address where we deployed it, and this is our ABI. So let's go here and let's copy our ABI. So we put it here. So the cool thing that it will do is that based on this array, it will generate the front end to interact with this contract. So if I go inside here, you see, he knows that we have one function to get a value, and we can call it, and we can see the response. And we have one function to set the value, right? So I can say one, I can execute, and it will just open our console. Yeah, it will just open our wallet. We sign the transaction, and we can go back here. We can call, and you see the response. It says now the value is one. Okay, so that's of course one way, but as I say, like that's useful. Like if you don't want to, like even if you want to go to production and you say like, okay, I would need maybe to build a dashboard for some specific settings, you don't actually need to do that a lot of times because you can just import in here your contract, your API, and you can interact with your contract, okay? But if you say like, okay, I will use it to actually test my contract, of course, like, as I said, it's not scalable because every time you deploy, it will just create a new contract. So you will need to go back, you will need to change the address. It will be like completely new instance of deployment. So I don't know, a lot of times maybe you need to do different actions in order to test a specific feature. Okay, so so we saw this, but oops, sorry. Let's go back here. And let's just see some other, okay, so for running the test, you just say yarn tests, and yeah, it's done. As I said, you can even run the coverage, so you can say yarn test coverage, and it will basically create a folder in here called coverage. You can open this in your browser and you can see like what was tested, how many times it was tested, the percentage and stuff like that. Okay, so let me just do this very quick. So let me init and push this repository. So one. I don't know why it's taking so long. Let me create a bit. Let's ignore basically modulus. Let's ignore what we have here. So sorry. Modulus. No. How is it? It's like this. Then our coverage, our amp file. We don't want to push that. And what else? Also type chain types. And coverage, artifacts. I think I'm doing something wrong, though. Whatever, I think it's enough. And cache also as well. Okay, so we say git, we already did it. Let's do a first commit. I think I'm doing something wrong with the folders here. Not sure. Yeah, no, something wrong. Okay, I will look into this later. I just remember. Okay, let's just push it. Like the important stem files, not push it. And let's just origin. Okay, so we will be able to just track the progress. It's pushing the not models. Okay, I will fix this later, but never mind. Okay, so now that we have this, we can close a lot of stuff in here. Okay, and we can focus on actually building our smart contract and actually learning about some smart contract features, right? So let's create actually a new one. So this is, yeah, first smart contract.solve. Okay, so as I said, we need to define SPX. Actually, let me just copy this one here and change the name. So first smart contract. Okay, so also what you see here, like this way of commenting, it's a sort of standard in Ethereum, so that yeah, you can specify like with notice what this function does, with params, the params that it receives and stuff like that. And you can even generate documentation based on this. Okay, so let me just delete this thing here. Oops. Okay, so what? Let's start from kind of the beginning. So what we can do, let's say first of all, like what are the type of variables that we can declare? Okay, so we have a sort of primitive variables that are one is address. So you can say, for example, owner. Okay, so address is just the address as you think about it. So this is a primitive type. Then you have integers and my number. Okay, you can have integers, and this one here you can even specify the size of the input integer that it will take into memory. So you could say like this is, you will just need 8 bits, you know, stuff like that. If you just write oint like this, it will default to this one here. Okay, so this is another one. Then you have string, my string. Then you have boolean, which is my boolean. So yeah, so those are basically the four fundamental type of variables that you can use in Solidity, the primitive ones. And an interesting thing about variables is that when you declare a variable, Solidity will actually also initialize it. Okay, so for example, if you create a variable of type address, it will initialize it automatically with this value here. Okay, with the 0 address. If you create an integer, it will initialize it with 0. If you create a string, it will initialize it with an empty string. And if you create a Boolean, it will initialize it with false. This is why when we went to the inspector previously and I said get value, it returned 0 for this one here. Okay. Okay, so those are the basic, the primitive ones, but you can build stuff on top. Okay, so one thing is, for example, you can create structs. So a struct is like you can define your own like the properties of your type definition. Sorry. So let's say like I have this struct where I have a number and a text. Okay, or for example, I can say like dog or person. Let's say user. User has like an address, and we say like this is the user address, and then we have like a string which is maybe the username, and we have something like that, right? So you can define your own structs the way you more like suits your objective, your goal. And another very important, and of course, like you have arrays, right? So you can create like this, and you can say like, though this is my, I don't know, instead of owner up here, I could say like those are owners, right? So it's an array of owners. It's an array of string. Okay, you can specify arrays. And a very important one is actually the mapping. So the mapping is, you can say like, okay, I want to create a mapping that given a specific address, okay, it will return, and he created here a mapping like pointing to my user struct. And you can say like, based on a specific address, it will return me a user. Okay, it's a sort of like multi-dimensional array, let's say. Oops, oh yeah. Okay, so in here you can say like, okay, users address. Okay, so you put here the address of the user, and you can say like, okay, in this position, like for this specific address, this return me like this one here, and it will actually store it in storage, right? So we have mappings, and mappings actually you can do multiple levels, because you could say like this address is pointing to another mapping of, I don't know, where you have an integer that actually points me to my user. Okay, so to have that, you could do something like that. So you say this address with this, maybe this is the ID, right? This is like, I don't know, user ID, something like that. Or I don't know, for example, you could have many nicknames, or I don't know, whatever. So basically you could select an address has many values, and then you use this other parameter here to say like, okay, give me this specific one. Okay, so this is another one. And last one is like, you can even create enums. So you can say like, okay, this is the state. I don't know, I have pending, active, and inactive. And of course, this will have value 0. This will have value 1, 2, and so on. Okay, so those are the basic things you can use in Solidity for variables. Okay, now let's move on and look at something else, at functions. Okay, so now you have, let's say I have exactly, I want a user, I want an address which is the owner, and let's say it's contract owner. Okay, let's do something like this. This is the contract owner. Then I have a user that has an address. Actually, I don't. Maybe we have just the username and the age. And then I want to create a mapping where I say like, okay, based like every user has an address. So how can I understand like actually, let's add the address also here. So address, user address. So given a specific address, return me a specific user, okay? And we can say like, I don't know, I don't think I will need this, I don't know. So let's say this is our storage. So what we could do, we maybe want a function to read the users, get all the users, and maybe we want a function to add a specific user, right? So when talking about functions, you should think about them as a sort of like if you think at backends, you have endpoints, right? You have a get endpoint that returns you data. You call it to read data from the backend, stuff like that. And you have, for example, post endpoints where you want to write data in the database and stuff like that. And functions are kind of similar. Like you create a function to read to read some data basically from the contract, and you can create some function to store some data in the contract. So as we were saying, let's create a function that is called like get users. Okay, what it will do, and actually like I could create it like this, but this is not enough. Okay, to create a function, like we need to say function, we need to say get user, but then we need two things. We need first of all to specify the visibility. Okay, so we have three types of visibilities. So one is public. So you say public, which means that basically everyone like can call this function. Okay, so you can call it from your front end, from your back end, from another contract, and so on. Another one is internal. Internal means that this function can be called only inside this smart contract or from another smart contract that inherits this one, and we will talk about inheritance in the future, but it's already 1 o'clock, so I don't think I will get it in time today. Let's see. So this is internal. So you are saying like, okay, only this contract can call this, only like this contract and other contracts that is inheriting me can call this one. And the last one is private. Okay, private means that basically only this contract can call this one here. So even if I have a second contract, let's say simple storage that is inheriting this first smart contract, it won't be able to call this one. Okay, so private doesn't mean because, and one thing, and you can add this visibility also to your variables. Okay, so in here I can say like this is public. Okay, and if this is public, it will what it will do, it will basically just automatically create a function called contract owner that returns no, not this that will return the contract owner. Okay, and I will show you why this is right in a few seconds. So by default, like if you say address contract owner is public, it will basically create this for you. Okay, not in the code, you won't see it, but you would see it in the ABI. Okay, another one, of course, you can call it like internal, or you could call it private. So we could say like, okay, this is private, for example. I don't know, it's for only for this smart contract. So our get users, actually, we want a public function, right? So we want public function. And the second thing that when creating a function, we need to specify is the type of the function, okay? So the type can be three types. A view function it means like it's a sort of getter. It's a read function, okay? And it means that this function can be called without actually paying any gas. You don't pay gas, anything. You can call it from other contracts as well, from your front end, of course. And you usually use this like view when inside the function you're going to read some data from your storage. Okay, so this is your storage. Okay, guys. So this here is like when you declare a variable outside like any function, that's basically your state. storage. Okay, this is your state. You can access this state in all the functions and so on. Okay, so if you're accessing your state in this one here, you call it view. You put view. Otherwise, if you're not accessing any state, you can just call it pure. So, for example, a pure function could be something like I don't know, calculate sum, and you put like you're adding two numbers. Okay, you're saying like this function accepts two parameters, two integers, and what it does, it just does the sum of those two integers, right? So it's not accessing any state. So this is just a pure function. Okay. In our case, of course, we want to access the state. We want to return all the users. So so we have view, pure, and we have another one, which is basically like if you want to store some information, so it's not a read one, then you just remove it completely. This will say like, okay, you are interacting with the chain, you are doing something, and there is another keyword, let's say, is you can say that these functions, it's even payable. Payable, it means that in order to be able to execute the code that it's inside this function, you need to send some ethers, okay? And just one thing about ethers on Solidity. So in here, let's put it right. For some reason, let's say you can do like this. So you say 0.1 ether, it's 1 ether, it's one way. Okay, so it's using like, even if you're building an application for VeChain, where we use VET, in like this Solidity is kind of agnostic about this situation. It's just for Ethereum virtual machine. So it will use Ethereum, it will use Way. Okay, so if you want to know more about like the conversion rate, just go on Google and search Way to G-Way, for example, something like that. And you can say like, okay, how much is one Way? How much is one Ethereum? And you can even get the extended one. So this are all the available ones, right? So Ether is in the middle, Tether is the maximum one, and so on. So inside your contract, that's the same. Okay, but let's get back to us. So we were saying we want a function. This is a view, and when specifying a function that will return something, you also need to say like what it will return. Okay, so you write here returns user. Okay, actually this is okay. So this user, okay, users, yeah. So let's make it a bit more simple. So we say like pass me an address. So user address. Let's do like this. Okay. So it says like, okay, it will return to you a user. So here we access our mapping, and we say like return me the user. Okay, this user that is stored here, like that we can access by this address. Okay, so yeah, so this is our getter. So we say like, and let's call it get user. So we say like, okay, get me, find me the user. And why we do that? Because we have additional information, right? We have the age, we have the username, and so on. One thing about this one here, so memory and storage. So basically, since all of Solidity works by using memory locations, it's really all about like how do you use, it's all about memory, let's say, in Solidity. So when you store something, like the nodes themselves, they need to store that information, right, in the storage of the blockchain. So that costs gas, for example. But sometimes when you just need to read something or you need some temporary variable, you don't need to store it actually in the storage. It's like the node just puts it in his RAM, let's say. So you say like, okay, this like initialize this variable, because here when it says returns, it actually what it does, it creates a variable named user, it's assigning it and it's returning it, but we just don't see it right here, okay? So we are saying like, okay, when you will create this variable here, call it user, store it in the memory, which means that, as I said, like you need to don't use any slot in the main storage, stuff like that, but store it in the memory. So when this function will end, you will just erase everything. It's like, yeah, when you turn on your computer, the RAM gets full, you turn it off, RAM is deleted, right? It's kind of the same concept. Okay, so another thing, yeah, so there are some variables that you need to, like, for example, integers. If I put here an integer, it won't, I don't need to specify that it's in memory because it's already in memory, but other, like, for example, strings, you always need to specify, like, hey, do you want it to save in memory or not, or whatever, okay? So we have our function to get the user. Let's create a function to actually set the user. So let's say add user, right? So when adding a user, what do we want? We want a username. So we say string. And here as well, we say with strings, we always need to specify this, like, okay, do we save it in memory? Like basically strings are always saved in memory. And we say this is the username, I can't write. Then what we have the age, and we say, okay, this is the age of the user. Oops, sorry. Okay, this is the age of the user, and this is the address, so user address, okay? We say that this is a public function, so anyone can call it, and what we do in here, we declare, we basically declare a temporary variable, okay, to say in memory, so it will be erased, just to declare. But what we do, we actually assign it here. So we go to the storage, to our main state, we go here, and we say like, okay, in this location, so in at this in this mapping, like for this address, this is the user. You can actually also put it like this. I don't think we will have any issues if I'm not wrong. Okay, so it's kind of the same thing. And what we did here, yeah, as I say, function, those are the parameters that we accept, visibility of the function, anyone can call it, and what it does. So in here, we will need to actually pay some gas to interact with this one. But let's say, and here I want to introduce another type of function, let's say, which is actually called modifiers. So let's say that I don't want anyone to add new users, but I want only the owner, the contract owner, to add a user, okay? What I can do, I can create a function, modifier. Yeah, okay. I can say modifier, and this is the keyword to actually, to actually specify that this is a modifier. And okay, oh my God. Okay, so what I do here, I will check. Okay, so let's analyze a bit this piece here. So this is a modifier called only owner. And this required here is basically a way to check in your code. It's a sort of if else's, right? If you want to check something and say like, okay, if this is not right, then don't do it. And we can even put this one here at the beginning, okay? We can put it here and then move it to a modifier. So let's do this first. So we say like, okay, to continue, we require, like this function requires that the message sender is actually the contract owner. Otherwise, revert the transaction with this error, okay, with this message. So, like I was talking about variables, right? So I was saying that this is our state. Like if we do something like this, like we were doing before, user memory, user memory, user, this is actually a local variable, Okay, so it means that it just lives inside this function execution. And then we have also some global variables. So this one here, message, is a global variable. It comes from the Solidity itself, okay? And you can say like message.sender, but you have another one, like block is another global variable. You can get the block timestamp. You can get the block number. Okay, so those, and here is like message sender is who is calling, who is the account that actually is executing this transaction. Okay, so in here, we are accessing this global variable and we are checking who is actually started this transaction. And we are checking like, okay, is it like the contract owner? If yes, we continue. Otherwise, we return this error. So let's say that we have a lot of functions, a lot of them, like, I don't know, delete user, right? Or rename user or whatever. And on all of them, we want that only the owner to actually be able to do that thing. Instead of copy pasting this in all your functions, and then in the future, you're like, okay, let's update something, then you need to go back and, I don't know, it's just, copy pasting code. We create a modifier, okay? So what we do, we can say modifier, only owner. We take this one here and put it here. And this here, it means continue like the execution of the code, okay? So basically it says, if this is okay, then continue, otherwise like revert, okay? So how do we use this modifier? We just put it here. So we say only owner, okay? So we say that we have this add user function that is public, but only the owner can actually call it, okay? And what it does, it will add in my storage a new user, okay? Okay, so, okay. So we have the get user, we have the add user. Let's also get function get owner that will return us the owner. And add user, okay. What else can we add here to make it interesting? Okay, so okay. So another things that we have like errors and events in Solidity. Okay, so let's say so events, think about them as a sort of console logs that are stored on chain. Okay, so you're doing a console log that is stored on chain forever and ever. Okay, it's still like it costs a bit of gas, but not as much as storing a variable. Because with events, what you can do, you can only fetch them and get them only from off-chain, so from your backend, from your front end, okay? Inside the contract, you cannot say like, hey, let's look at the old logs that we emitted, right? You cannot do it inside the smart contract. You can do it only like outside the smart contracts, okay? So this is why like it's a sort of still like free storage, let's say, that you can use maybe to that then later you can build indexers on top, like that you use the events to actually like add data in your database and stuff like that. So let's say that we want to emit an event, like the event is a new user was added, right? So what we do, we first need to define our event. So we say event new user added, okay? And we put in here like, okay, what are the parameters of this? Like, what are we actually like logging, right? So we are saying we'll log the username, the age, and the user address. So what we do here, we say, okay, emit new user added, okay? And we pass the variables that we had here, okay? So super easy, super handy. So we say like, okay, this is our event, and we emit it, and that's it. But another thing that we can do, we can, for let's say that we say like, okay, but in the future, like I will have a lot of events. So let's say that I want to get the events only for like all the users that I added with a specific age. What do I need to do? Do I need to like fetch all the events and then, I don't know, iterate them, stuff like that. Like if you leave it like this, you will need to do it. But what you can do, you can say like this is indexed, okay? So basically now from off-chain, as I said, from your frontend or from your backend, you will be able to say, give me all the new user added events for this age, okay? And you will just get those logs back, okay? So this is the event, but another thing you can do, you can specify error. So you say like error, unauthorized access, okay? So here, for example, instead of emitting a custom kind of message, a string, what you can do, you can say like, you can do this, okay? You can say if message sender is different by from the contract owner, then revert the transaction with this error here, okay? And in here, you can also put variables. So you can say like the address caller, okay? Who is the address that called, and you put here like sender. So basically, we will see that, hey, this is unauthorized access, the transaction reverted, the error was emitted, and this is the user that actually tried to access whatever function it was trying to access, okay? And let me think of another thing that I wanted to show. Events. Okay. So, but there is one bug at the moment, okay? So we were saying that variables, when we create them, they are already like initialized, right? So this contract owner will be 00000, the zero address, which is not good because we want to be the contract owner, we the deployer. So how we do that? We will need to basically create our constructor. So say constructor. As I said, this one is called every time only on the deployment, and that's it. And we set this variable contract owner to the message sender. So basically the one that the account that is deploying the contract is the contract owner, right? Okay. Get owner, add use, add user. What else? I think we could be good to go, and we could deploy this contract and play a bit with it. Actually, just before that, I want to touch on a very last, no, it's no time. We will figure it out in the next lesson, but I want to show you also another thing. No, yeah, neither this one. Okay, so this is our contract. So let's deploy it. Okay, so we go inside here, and we want to deploy our contract, our new contract. So let's say const. Sorry. First of all, let's see if it works. Okay, so first of all, we need to try to compile it and see if we have if we did anything wrong while writing this contract. So yarn compile. Okay, everything is fine. Let's then, at this point, when we did yarn compile, it also added the types and stuff like that. So let's deploy it. So we say const, this is our, how we called it, first smart contract. Wait, headers get first smart contract. Then, then we deploy it and we say who should deploy it. We just get the signers from the mnemonic, and we take the first account, and we will use that account as our deployer address. And then let's wait for the deployment to finish. Let's, what's that first? Because yeah, let's return it in here. So, well, this is not actually needed. So let's not worry about this, but let's just do a console log. Okay, so let's do console log. Okay, this is not right. It's like this, get address. Okay, so we console log our address, and let's deploy it on testnet. Yeah, deploy testnet. It will actually deploy also the simple storage contract, but who cares? Okay, so this is our address. Okay, so let's go here. Let's go to the inspector that we were using before. Let's testnet. Let's add our contract. This is our first smart contract, and let's get the ABI. So we go artifacts, contracts, first smart contract, and here we get the ABI. Okay, we put it here. And let's try it out a bit. So first of all, let's check that the owner is me. Yes, it's this one, right? It's the torso mnemonic. If I open, you see, yeah, you cannot actually see it here, but yeah, it's this one. And so this is like the constructor run correctly. We are the owner. Let's try to add a user. So we say this is done, 32, and the address of done is this one here. So you see, now I switched account, right? To copy my address, I went to another account inside my vWorld. So let's see what will happen if I try to execute and I try to sign this transaction with this account. It should revert, right? So let's execute. And it already says like, hey, man, this will fail. Sorry, this is in Italian, but trust me. And let's actually see the transaction failing. Yeah, you see, reverted. If we provide the ABI, like if we make the ABI public, we will also see the reversion reason, but you can, like, that's one way to test it, but we have this button here, call, okay? What this will do, it will just simulate the transaction. So we can say like, hey, what happens if this address, so the caller is this address, and it tries to call this smart contract function with those parameters, we click call, it's just a simulation, and see, it will say, hey, reverted, okay? Okay, so, but let's just add our user with our root wallet, execute. Okay, so now, even if we try to call and to simulate it, let me take, oh. Okay, cool. You see everything reverted false, so everything would be work correctly. So now let's get to read and let's say like get the user, right? So I'm going back to this one. I say call, and here it is. So it returns to me like this user, right? This is my struct. It's a tuple, I don't know how to say it in English. So the username, the age, and the address. Okay. And one thing we can take a look is the events. We have this tab, so we can just say like, okay, show me all the events that were emitted of new user added. And we can see here that in this block at this time, this event was emitted, and this one here was indexed parameter. Okay. Okay, so our smart contract works as expected. I wanted to talk also about, okay, I actually have, but I would make it in time. So, yeah, but one thing, this is important. Just to close everything. So we saw that we can do if-else, ifs, statements. What we can do, we can also say like function get user by username. Okay, get user by username, which accepts a parameter which is this one here, and will return we return this user. And what we can do for loops. Okay, so you can say like, okay, just take basically all the users that we have in like take this array of users, iterate over it, and try to find. Actually, I don't think it will work. By the way, we created the contract, but it doesn't matter. So we can do this. We can also use while loops. So we can say like while true, whatever, or just normal while loops. And we can also use try catches. Try catch, like try to do this and catch, like it will revert. But one thing is that try catches actually work only with when calling other contracts or other functions. Okay, so like if you say like you cannot just say like try to do something in here, and if something goes wrong, then revert. No, it's like try to call this function, try to call the function of this contract, and if it reverts, if something goes wrong, then enter the catch. Okay, so basically this is what you can do in Solidity. So for loops, while loops, try catches, if else statements, and that's it. But what I wanted to say is that you should really take care, like you should avoid as much as possible loops, okay? Because every time you do something, you execute a function, you do something on chain, even if you just read, okay? What happens is you are asking a node to do that. The node will use his computational power to do that stuff, right? It has a limited time. He has limited resources, and you don't want those attacks, stuff like that. Like if you do a while true, for example, in here, of course, it will never end. So like you need to set some limitations, right? So what they do, basically everything you do in every function, for example, here to create this variable, you are actually spending gas. Okay, you're spending money to do this. To emit an event, you're spending gas. To just call and interact with a contract, you spend like 23,000 GWay, something like that, GWay. So everything you do, you're spending gas, right? So if you do, and you have a gas limit, so basically Solidity says like, hey, look, you cannot use more than 20, I don't remember exactly at the moment, but I think it's 21 million of gas, right? So if you create something like this, a while loop or a for loop, even not intentionally, just let's say you're doing this, you're saving an array of users, and you say like, yeah, okay, I will just iterate through all the users to find this one specific. Well, if your app scales and you have tons of users, that for loop could take like a lot. By every time you do a check and you check in the memory, you check in something, you're spending gas, you will reach that gas limit, and the transaction will just revert. It doesn't matter if it's a getter, if it's a setter, whatever, the transaction will just revert, okay? So yeah, try to, like, it's not that you cannot use, like, you can use for loops. If you say like, okay, I'm sure that it will never iterate, I don't know, more than 100 times or more than 300 times. So it's fine, like it's scalable, like use it, but just this is very important because to get right from the start, because if you from the start just don't think about this and use for loops and while loops everywhere, and then you arrive at a point where your smart contract scales, then basically what will happen is that your function will start reverting. And since this is a not upgradable smart contract, it's a normal contract, you won't be able to update your code anymore. And what happens? like your app is broken. You cannot use your contract anymore to read data. Maybe you can use it to store data if you're not using for loops or stuff like that, but to read, like, you cannot use it anymore. And just to conclude, like, this is a non-upgradable smart contract. Smart contracts, like, once I deploy it, this one here, that's it. Okay, I cannot say like I can interact with it, but that's it. The code is that one, and it's done. Okay, so if I say like, oh, there is a bug here. Okay, like for example, I don't know, there is a bug, right? So I need to fix it. The only way you have is to actually deploy a new contract. Deploying a new contract will generate a new address. Okay, so if you have users on your platform that already, and you added already like, I don't know, 100 users, you deploy a new contract, you need to choose like, hey, okay, what do I do? Do I still point to the old contracts and fetch users from there? Maybe the first 100 users from there, and I also add this new contract, and the next one I will fetch them and add them in this new contract? Or do I just put the old contract in the trash and use the new one? Like, what should I do? It's like you need to choose. Usually you will need to maybe migrate all your old users to seed this new contract, but for a lot of applications, that's not doable. If money is involved, if like, I don't know, it really depends on the type of application you're building. So this is why upgradable smart contracts are kind of the way to go, in my opinion, because you can take your time to actually, if there is some bug, if you need to change something, you can update your contract, right? You can upgrade it. And when you're like, okay, this is fine and this is working perfectly, you just say, okay, you can renounce the roles, and say like, okay, this is not upgradable anymore. But we will touch upgradable smart contracts in future lessons, and our time is up. I hope you enjoyed it. Looking forward for the next lesson. Cheers, everyone. Thank you.